In this video, we are going to be looking at real number storage using the IEEE Standard. We're going to look at taking a decimal number and writing it into IEEE, and we're also going to be looking at taking a number that's been written in the IEEE Standard and converting it back to a decimal. So our first question here is negative 93.25. We want to take this decimal number and put it into real number storage using the IEEE Standard. So the first thing we need to do is to write this number in binary. So I'm looking at the whole number, just 93, and I want to write that in binary. So I'm going to use a face value, place value chart for this, looking at the powers of 2. So I have 2 to the power of 0, which is 1, 2 to the power of 1, which is 2, and so on. So looking at this chart, the highest that I can go without going over 93 is 64. And if I use the 64's place, then that means I will have 29 numbers left to use. So the highest I can use is the 16. Which gives me 13 left over. So I can use the 8, which gives me 5 left over. So I can use the 4 and the 1. So if I do 1 plus 4 plus 8 plus 16 plus 64, I should get back to 93. And I'm just going to put zeros into these empty spots here that I haven't used. So that means that 1, 0, 1, 1, 1, 0, 1 is the same as 93 in decimal. Now I want to write the 0.25 as binary as well, and to do that we're going to use a different method. We're going to take the 0.25 and we're going to multiply it by 2, which gets us to 0.5. Okay, I'm going to record the 0 and keep going with the 0.5. So I've got my whole number here, and I know the first part of the decimal portion of that number is a 0. And I'm going to keep going with 0.5, and I get 1.0, so I'm going to record this 1. And then if I was to continue to go with 0, I would just end up with a bunch of zeros. So that means I can stop here. So 0.25 is going to be the same as 0.01. So that means my whole number here, 93.25, is 101101 decimal 01. So I now have my 93.25 in binary. I'm going to take that number and I'm going to put it into normalized binary form. So if I have the number 101101.01, and I want to put it into normalized binary form, which is basically scientific notation of binary numbers, then I want to put my decimal portion here. I'm going to move my decimal to that spot. And to move it there, I have to jump 1, 2, 3, 4, 5, 6 spots. So my normalized binary form is going to be 1.011100101 times 2 to the power of 6, because I moved 6 spaces. Okay, so that's kind of the first portion of this question, is we need to write it in binary and then write it in normalized binary form. Once we have it in normalized binary form, we can take these pieces in order to write it in the IEEE Standard. So the first part of IEEE Standard, we kind of switch colors here, is the sign bit. So our actual question was negative 93.25. So to represent a negative, I'm going to put a 1 in that first bit, that first space. The next 8 spaces have to do with the 6. So I'm going to take the 6 I'm adding 127. We always add 127. And I get 133. Now 133 in binary, look at our chart. I'm going to put a 1 in the 128th place, which leaves me with 5 left over. So I'm going to do the 4 and the 1. And I want to use all 8 bits here for the next portion of our IEEE standard. So this is going to represent my next 8 numbers, which is 1, 0, 0, 0, 0, 1, 0, 1. The final 23 bits come from this portion of the number, not counting the 1 decimal. So we ignore the 1 decimal and we ignore the times 2 because those are common in every one of these types. Every normalized binary form is going to have 1 decimal, something times 2 to the power of something. So we don't want to use a space to represent the 1 decimal and the times 2. So I'm only going to do the fraction part of this number, which is 0, 1, 1, 1, 0, 1, 0, 1. And because there's no repeated pattern here, this is the end of the number, I'm going to fill up the rest of the spots with zeros. So all together, I'm going to have 32 bits. The first bit representing that it is negative, the next 8 bits coming from that exponent, and the rest of the 23 bits coming from the fractional portion of the normalized binary form. So my final answer here is this 32-bit combination. Next, we're going to look at how we take a number from IEEE Standard and put it back into a decimal number. So again, the first thing I see is that it is going to be positive. So my final answer is going to be a positive number. This next section represents that exponent on the 2, right? When we think back to normalized binary form, it's going to be 2 to the power of something, and that something is represented by this set of binary numbers. So if I expand this out, I only have a 1 in the 128th place. So that represents 128. But remember, when we wrote the binary number for our exponent, we added 127. So I'm going to subtract 127 from this number, and I get an exponent of 1. So that means that our answer is 2 to the power of 1. And finally, this portion of the number is going to represent the fractional part of our normalized binary form. So I'm going to add a 1 decimal to the front, and I can ignore the rest of the zeros. So that means the normalized binary form that this represents is 1.111 times 2 to the power of 1. So my job now is to take that and put that into decimal form. So I'm going to expand my binary number. So I have 1 times 2 to the power of 0 plus 1 times 2 to the power of negative 1 plus 1 times 2 to the power of negative 2 plus 1 times 2 to the power of negative 3. And all of that, that whole thing is going to be multiplied by a 2 to the power of 1. So my first set of brackets there is going to be 1. 1 times 2 to the power of negative 1 is the same as 0.5. 1 times 2 to the power of negative 2 is 0.25. And 1 times 2 to the power of negative 3 is 0.125. And that's all going to be multiplied by 2 to the power of 1. So I get 1.875 times 2 to the power of 1 is 3.75. So my final answer is positive 3.75 in decimal form. So to kind of summarize, to write a number into IEEE Standard, you're first going to write the number in binary. Then you're going to put that number into normalized binary form as shown in the red color there. And then you're going to use that to write into IEEE Standard, the first one representing whether your number was positive or negative. In this case, it was negative 93.25, so I'm going to put a 1 there. The next 8 bits represent the power on the 2, and the rest of the bits represent the fractional portion of that number, not including the 1 decimal. Then to put our number back into a decimal, again, that first one tells you whether your final answer is positive or negative. You're going to take the next 8 bits and expand it, and then subtract 127 to get the power on the 2. And then the next tells you the fractional portion of the number, so you're going to add a 1 decimal to the front of it. Putting that together, you get your normalized binary form, which you then expand out to get back to your decimal number.